Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic equation by using the quadratic formula. Alright, so without further ado, let's begin. Now, in our previous video, we did look at how to use the method that we call completing the square to solve for quadratic equations. We also established the fact that there are other methods of solving quadratic equations, such as the graphical method, as well as the use of the quadratic formula. Now, in this video, I want to use the quadratic formula, but before we do that, let's look at how the quadratic formula was derived before we use it to solve the quadratic equations. Now, we established the fact that our quadratic equations are of the form ax squared plus bx plus c is equal to 0. Now, we'll be using the method of completing the square here to derive the quadratic formula, and then we use it to solve any problem that will be given to us. Now, I said in a previous video that in solving any equation that involves the use of the method of completing the square, always make sure that the x squared term is 1. So that means I have to divide each side over here by a to get rid of the a that is attached to the x squared side over here. So I have x squared plus b on ax plus c on a is equal to 0. Now, after that, we have to rearrange this equation by sending the constant to the other side of the equal to sign. So I have this plus b on ax is equal to negative c on a. Now, the next thing we do over here, we find half square the coefficient of x, half square coefficient of x. That is, we add half square coefficient of x to both sides of the equation. Now, if you look at the coefficient of x is b on a, and half of that is equal to b on 2a. So if we square this becomes the half square. So this expression all becomes s squared plus b on ax plus b on 2a squared is equal to minus c on a plus b on 2a all squared. So this is what we get. So from here, now this is a perfect square, so we can rewrite it as just a plus b on 2a all squared. So it becomes a plus b on 2a all squared. If you like, if you expand this, you get this expression that you have over here. So this is what we have for this expression. So this is now equal to minus c on a plus this. If I expand this, it will give me b squared on 4a squared. So I can rewrite this as this 2a all squared is equal to, then I bring this guy first, so b squared over 4a squared minus c on a. Alright, so I maintain this side, x plus b on 2a all squared is equal to, the LCM between this and this will be equal to 4a squared. So I have 4a squared over here as my LCM. So 4a squared will go into 4a squared one time. 1 times b will give me b squared. Then minus a will go here 4a times. So 4a multiplied by c will give me 4ac. Alright, so from here I need to get rid of the square term to make x the subject. So I find the square root over here. So this becomes plus or minus the square root of this entire expression. Since we are introducing a square root sign, we introduce plus or minus. This cancels this, so we have x plus b on 2a is equal to plus or minus the root of b squared minus 4ac all over. Let me rewrite this as sorry, let me just maintain that 4a squared over here. Alright, so from here, the next thing I do is that the 4a squared over here that I have, I can rewrite this equation as, instead of writing 4a squared, I can write 2 squared a squared. Okay, so it means that these guys will cancel the root that will be at the bottom over here. So I'll just have this expression will be x plus b on 2a is equal to plus or minus. The root is not just affecting just the top, that is b squared minus 4ac on 2a. Now the root doesn't extend to the bottom again since the 4a squared is now 2a. Alright, so from here I can just maintain my x here and bring this guy to the other side of the equal to sign. So I have my x is equal to minus b on 2a plus or minus the root of b squared minus 4ac on 2a. Now you realize that we have 2a here, a common denominator, so we can rewrite this entire equation as s is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. Now this expression, that is s is equal to minus b plus or minus the root of b squared minus 4ac all on 2a, this equation is what we are calling the quadratic formula. Quadratic formula. So once you've been given a quadratic equation, you substitute the value of your a, b, and c into this equation, you can get the root of the equation very easily. So we obtain this information by using the method of completing the square on the general expression of a quadratic equation to get this formula. So this is the formula we'll be using in today's video to solve for problems. Right, so let's go ahead and look at an example. So we have to use the quadratic formula to solve the following equation. So we have 3x squared minus 6x plus 2, and then x squared minus 2x plus 2. Alright, so this is the equation that we are supposed to solve using the quadratic formula. So let's look at that. Now if you look at these expressions really well, you realize that we cannot factorize this equation, and so we need to use another method, that is either the method of completing the square or the quadratic formula. But since the question is saying that we should use the quadratic formula, let's do that. So in order to use the quadratic formula, we have the equation 3x squared minus 6x plus plus 2 here is equal to 0. Alright, so that means that my a term, which is the coefficient of the x squared term, is 3. My b, which is the coefficient of the x term, is minus 6. And then my c, which is the constant, is 2 over here. So that is 2. Now I can write my formula. My formula is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So this is my formula for finding the value of x. So I do the substitution. I have minus b is 6, b is 6, so minus 6 plus or minus the root of b squared is minus 6 squared minus 4, a is 3 multiplied by c, which is 2, all on 2 into bracket a, which is 3. So this means that my x is equal to plus 6, negative will give me positive, plus or minus the root of, now minus 6 squared will give me 36, minus, now 3 times 2 will give me 6 multiplied by 4, that will give me 24, all on 2 multiplied by 3 will give me 6. So x is now equal to 6 plus or minus the root of 32 minus 24 will give me 12, all on 6. So my x values are 6 plus root 12 on 6, or 6 minus root 12 on 6. Alright, so 6 plus root 12 on 6, this will give me the value 1.577, or 6 minus root 12 on 6 will give me 0.423 as my answer for x. So if the question demands that you leave your answer in a set form, you can leave your answer here. This is also correct. But if not, you just use your calculator, punch these guys into the calculator and get your answer in this form, always to 3 decimal places. All right, so let's go ahead and find the second example. Let's do that. So the second example, we have x squared minus 2x plus 2 is equal to 0. This means my a term is 1, my b is -2, and my c, the constant, is 2 over here. So my quadratic formula is x is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. So my x is equal to minus b is minus into bracket minus 2 plus or minus the root of b squared will be minus 2 squared minus 4. A and c is 1 multiplied by 2 all over 2a. So my x is now equal to, this will become positive 2 plus or minus the root of, this is 4 minus, this is 2 multiplied by 4 will give me 8, so this becomes minus 8 all over, the a here is 1, so this becomes 2. So my x is now equal to 2 plus or minus the root of 4 minus 8 will give me a -4, so I have -4 on 2. So my x values are 2 plus root -4 on 2, or 2 minus root -4 on 2. Alright, now root of negative number will give you a complex number, so we can leave our answer as it is over here in the complex in the set format, because if we point this into the calculator, we'll be getting 2 plus I root -4 and some other stuff, which is a complex number. We don't want to deal with complex numbers in today's video, so we can just leave our answer in a set form like this, and that will be all right. So this is how we use the quadratic formula to solve quadratic equation and get the roots of the equation. So thank you so much for watching, and I will see you in the next video. Bye bye.